Hello and welcome. It's about 8:30 p.m. on Saturday, May 10th, and this is my paper that I'm working on. It's not finished yet. I need some more examples just to drive it home. You know, not every cloud turns into a thundercloud. That's because either the pressure's wrong or the temperature's wrong, and it just doesn't get the power going until it hits this specific point. This is actually what you'd have to put in to the algebraic mesh 3 physical laws to meet that value where x turns to 1, x being the combined properties of Einstein, Newton, and Coulomb. Let me back up a bit. So I'm using this algebraic mesh 3 physical laws to explain what water energy triplicity is. And it seems to line up with the graph. If you have this graph here, I'm saying that the quantities you need to make x equal 1, an example is here. Mass 90 kilograms, charge 9 coulombs, and energy 6 joules. And I found that this combination causes x to equal 1, and we get, here's L, which is the combined gravitational speed of light, the electromotive constant. You'll find these numbers in almost every physics textbook, that speed of light is this, nearly 3 times 10 to the 8th meters per second. You got the gravitational constant, Einstein times Newton divided by Coulomb's law. G, which is the gravitational constant, times the speed of light squared over the Coulomb's electromotive force constant. So these are the right way around. Now, what you could do is you could flip the ratio from, you flip Newton and Coulomb, and you'll get a different number, but you'll get the same x, because what we're looking for is x equals 1, and the constant makes it right. If you have the right values, you can flip it over, and it's essentially the same thing. I'm basically saying that here. And this x equals greater than 1. X is greater than 1, then Newton and Coulomb ratio flips like tangent and cotangent. Time resumes in normal flow again. So what we're trying to do is get x to pass through that equals 1 point, which it's going to do if it flips the other way around. And we end up with the time stretching out to infinity. Get time. See, if x equals 1, you square it, subtract it from 1, you get a 0 in the denominator, making time stretch out to infinity. Yeah, so it has to pass through that x equals 1 to go from one side to the other. And that's the macro version of my equation. There we go. So we have G. Let's start with 299792458. Then we need to square it because it's squared down here. Squared down here You just square it. Then we go multiplied by 6.67408 exponent change the sign 11. So we got 11 equals this, and then we go divided by 8.97 exponent. What is that, 9? I think so. Equals. Isn't that a reasonable number? None of those get even close to as agreeable as that number. No. So if we and it's like just four decimal digits away. 1, 2, 3, 4. So if we multiply, and that's this number right here, pretty close here. 7407999. So yeah, pretty close to the right number. Let's store it. Let's store it. Put it in memory. Okay. And then we're gonna go. How do we plug our example in? So we got. So our equation is this for x. So we go m. Our m is 90 kilograms, and we cube it. Cube it equals this, and then we divide by charge, and our charge in our example is 9. So we go charge divided by charge, which is 9. We got to square it. And then we go equals, and we divide by 6. Divide by 6 joules. And then we multiply that. Multiply that by our L value equals. Look at how close to 1 it is. We're aiming for 1 exactly. And those are pretty reasonable values. And it's got to pass through 1 to get there. You know, I can refine the numbers better, but I like the integers. Again, this is just an algebraic mash of what you're going to find in your physics book. As long as you don't break any, uh, as long as you don't break any algebraic rules, and you combined uh, Einstein's relativity with Newton's gravitation equation and Coulomb's electromotive force. Yeah, it's basically setting Newton and Coulomb equal to each other. And when you do that, you're going to get a unitless ratio because all the units are going to match on both sides of the dividing line. And they're going to cancel each other. So you end up with a unitless ratio. And then when you multiply it by an energy, you're going to combine them together into one equation that everybody thought you needed calculus to figure out, or some different way of thinking about things in order to make sense out of it. But no, all you need is algebra,